All right. Let's work on this guy. So we want to determine the absolute maximum moment in the beam. You might remember we talked about that last time, and that's that technique where about the center line you balance each force with the resultant force. And since we had three forces in our system, we need to do three cases. So the first thing we need to do is we need to find the resultant force and its location. So the resultant force is an easy calculation. You just add up the three. So that would be 2 kips plus 1.5 kips plus 1 kip. That looks like 4.5 kips. Now the resultant, what I like to do is draw a little picture. And I'll just start with the one on the far left. So there's 2 kips, and then some distance back. Oh, never mind. That's right. 1.5 kips, and then 1 kip. And that is 8 feet and 4 feet. So I'm gonna sum the moments of this about this back point here, P. And somewhere in there is my resultant force. So I would measure that from P this way. I'll call that X1. Okay? So remember, the force, we've already know that the forces are the same because we know the resultant is the equivalent of the 3. So now we want to have the same moment capacity. So if I sum moments about that back point P, I called it, what do I get? Well, the 1 kip will create no moment. I'll get the 1.5 kip force times 4 feet and the 2 kip force times 12 feet. And that equals 6 and 24, 30. Does that look all right? 30, bless you, kip feet. And then if I do it again, this time just using the resultant force, right, I will get the resultant force, which I know is 4.5 times X1. So these two things have to be equal. So we can solve for X1. It should be 30 kip feet divided by 4.5 kips. I don't know what that is off the top of my head. A little more than 6?
6.67.
6.67? Anybody else get that?
6.7, I'm sorry.
6.7?
Yeah.
So we got that condition. So now we're going to have 3 cases to deal with. So I'll just call this first one case 1. And that's where we'll take the front load and balance it with the resultant force about the center line. So let me redraw the beam for reference. And let's look at AY and BY. And then I'll put in the center line. And then we need to look at a balance between these. So this is 6.7 feet. The total here is 12. So the distance from 2 to this thing would be 12 minus that, or 5.3. And that's the distance between these two, and that's the distance we're going to have to split. So here's my 2 kip force balanced with the resultant force, which is 4.5 kips. And the distance between those will be the 5.3 divided by 2, which is going to be what? Something really strange. 2.67? What's that? That's close enough. Probably with the rounding, it's probably 2.67. It's actually 5.33333, isn't it? What's 5.333 divided by 2?
That's the 2.67.
I believe you. 2.67. That's 2 2.2, right?
Yeah.
I'm going to write it that way. 2 2/3 feet. And then we go back to the 1.5, and we go back to the 1. Now I know the difference between there is 4. And what's the difference here? Well, that was 8. That's 6.67 minus 1. That's 2.67, right? Another 2 2/3. Is that right? I think so. So that's another 2 2/3. Strange dimensions there, unfortunately, but that's the way it goes. Now remember, case 1, we're balancing 1, so we're really looking for the moment under here. I'll just call it M1. Okay? So that means ultimately I'm going to cut the structure there. And you decide whether you want the left side or the right side. I think the left side is clearly the advantage. So we want to find the reaction at A. So let's come over in some moments at B and make sure our structure is in equilibrium. Now again, you can work with all the forces or just the resultant. I think in this case you can see the resultant's going to be a lot easier to work with than dealing with 3 forces. So the moment about B, the resultant force creates positive moment. It's 4.5 kip force. What's the distance from B to the centroid? Well, this is 15 feet, and it'll be 15 minus the 2 2/3. So that should be 12 1/3. That make sense? This is from B to here. And then AY is negative moment, and it is a moment of 30. So what's AY? I think it'll, I don't know whatever that is. Something like 2 something?
1.85.
1.85? Anybody else get that? Yes? No? Maybe? Anybody? Bueller? No? Okay, I'm going to believe it's 1.85. Wow, you guys are really in another world today. 1.85? And that will be in kips. So now I can cut my structure. And we know the reaction is 1.85 kips. And I'm looking for the moment there, which I'm calling moment 1. That's the positive moment. And what's that distance going to be? Well, this section is also 15 minus 2 1/3, so that'll also be 12 1/3 feet. And if you sum moments there, what do you get? You get the internal moment M1. You get the reaction 1.85 kips times a distance of 12 1/3 feet. And that is 22, I'm guessing. Anybody? Anybody on a calculator? Abacus?
22.8.
22.8. Anybody get 22.8?
Yep.
All right. And that'll be kip feet. Only on Tuesday. Only on Tuesday. That's a lot of work.
Quick question.
Yeah.
So when you make your cut and you're taking the moment, you take it about the first force?
You take it under the force that you're balancing the resultant with.
Okay.
So the next case that we're going to do, we're going to balance the resultant and the second force.
Right. So you'll take it at that second.
And that second force would be just to the right.
Right.
And we'll take a moment into that. And then the third case will be these two. All right, so I gotta make some room because I don't have enough on my page here to continue. Give me just a second. So we'll flip that one over, and we'll start again with case 2. So again, we'll start with the same beam. We'll have a reaction at A, a reaction at B, and then about the center line, we're going to balance our load system. So remember, we're looking at this as our system. So we want to balance the resultant force and the second force about the center line. And what's the distance here? That's 2 and 2/3. You divide that, you get 1 1/3, right? So from the center line, 1 1/3 to the left is the resultant force. 1 1/3 to the right is the. I can't draw that to scale, so I'll just put 1 1/3. 1 1/3 feet, and on the left side, that's my resultant force, 4.5 kips. On the right side is the second force, which is 1.5 kips. And then 4 feet back is the 1 kip force, and so many feet forward is the 2 kip force. And that distance there, we also had solved this distance here. And I believe that was, what was that before? That was 5 1/3, wasn't it? Because this was 8 feet. This was 12 total, and we went 6 2/3, so this is 5 1/3. That make sense? And we're looking for the moment here. Call that M2. So that's probably where we'll cut the structure. You have to decide left or right. Yeah, right's going to be. So this is the first time in the problems that we work here in class that because we have 3 forces, when you cut this middle force, no matter what side you look at, you're going to have to deal with a force in addition to just the reaction. So we will go right, so we'll need the reaction at B. So let's sum moments about A, and that will give us the reaction at B. And just like before, we're only going to use the resultant. So about A, our resultant force creates negative moment. The force is 4.5 kips. And what's the distance from A to here? Remember, the total distance is 15. So 15 minus 1 1/3 should be 13 2/3. And then over here at B, B creates positive moment, and the distance from A to B is 30. So what's BY? 2.05? 2.05, and then it'll be kips. So now when we make our cut, we're going to know that BY is 2.05 kips. We're going to know this 1 kip force is 4 feet back. We've got our moment at 2. And what's that total distance of this piece? Well, it's going to be 12 minus 1 1/3. It's also going to be 13 2/3 feet long. and it's not to scale. So now when we sum moments about the cut, and we'll use right-hand rule for our sign convention, what do we have? Well, the internal moment's negative. The moment of the 1 kip force is also negative. That'd be 1 kips times that moment arm of 4 feet. Our reaction creates positive moment. That's 2.05. That's the value we just solved. And it'll be times the length of the segment, which is 13 2/3 feet. And I'm calling that moment 2. So what is moment 2? This is like 27 minus 4. It's going to be like 23 something, maybe 24 something. Just guessing.
Pretty much 24 on the dot.
24 on the dot. And one thing I forgot to do over here, which I want to go back and say that that's the moment, but where is the moment? It's at this point, which would be at 12 1/3 feet from A. Now this one is here, which is going to be at 15 plus 1 1/3. That's going to be 16 1/3 feet from A. And comparing the two right now, it looks like the one at 2 is controlling. We do have one more case to check. That would be when we balance the resultant force and the 1. And I've run out of paper. Nope, I found another page. Here it is. Okay. So here we go. So case 3. So again, I'll draw my structure. We'll assume a reaction at BY, one at AY. We'll go back and find the center line of our beam. And now you might remember we want to balance our reaction, our resultant force in 1. So that's 4 feet. Well, actually, the distance between here is x1, which is 6 2/3. If you cut that in half, you get 3 1/3, right? So let's see. I'm going to have 3 1/3 feet over, and I'll hit my... Oh, that's a different problem, isn't it? I'm going to use the page anyway. Don't ignore that. That's a 1 kip. And of course, 3 1/3 feet forward would be the resultant. So I want to put that in there first, just to show you the balancing part. Now I got to go back and find all my other forces. I know from the resultant forward is the 2 kip, and we figured that out before. That was the 5 1/3 feet. So up here to the front is the 2 kip force, and that's at 5 1/3 feet. And then where was that in between force? The 1 1/2. It was 4 feet from 1, so it's going to be on just here. And that was 1 1/2. Of course, it's 4 feet here, and this is 3 1/3, so that little distance is just going to be 2/3 of a foot. Kind of crazy geometry. A little confusing, but you can see all the different pieces. And don't forget, we're cutting this in the center, so each of these segments is 15. And I'm going to be looking under what force? This one. And I'll call that M3. So we're going to cut the structure there. You want to work left or right? Right. So we want BY. So if we sum moments about A, make sure it's in equilibrium, we should be able to get By. And again, using just the resultant force, about A, my resultant force will create a negative moment. That'll be 4.5 kips is the force. The distance from A to here, well, this is 15 minus 3 1/3 is 11 2/3. And then, of course, my reaction at By creates positive moment, and that's the complete length of the beam, 30 feet. So what's By? No, 1.75. Oh, I was going to guess that. No, I wasn't. 1.75. All right. So then I can come down here and now look at my structure to the right. I found By. It's 1.75 kips. I'm looking for the moment there. I've called that point 3. And I know the distance of that little segment, it's this. So I know this is 15. And again, minus 3 1/3 should be 11 2/3. And if you sum moments about the cut, make sure it's in equilibrium. What do you have? Well, the moment here is negative. About the cut, the 1.75 creates positive moment, 1.75 kips. And what's the distance? We just figured out 11 2/3. So it looks like the moment at 3 is, I don't know, 20.4. And that would be kip feet. And that would be at this distance, which would be 15 plus 3 1/3, which is 18 1/3 feet from A. So now we got our 3 cases. The final solution is just to review it. So we got 20, 22.8, and that was first case 1. Where did case 2 go? I put it underneath that one. So it looks like the final answer, the max, is equal to 24 kip feet, and that's case 2, which was 16 1/3 feet from A. Okay, so a little review. This is not doable in a 15-minute window on the exam. It just took us 22 minutes to do it. So a 3-case scenario would be unlikely. A 2-case scenario, though, likely. So keep that in mind. So any other questions about this before we move on? All right, that's the last problem of the semester. All right, that's enthusiastic. Yes.
I was trying to give my partner a high five, but he's not as enthusiastic.
Well, speaking of high fives, let me turn this off. I don't think this needs to be recorded.